Question 3. In an atom, the electrons occupy subshells in order, increasing energy. Complete the table below to show the order in which the next two subshells are filled. So when you were first taught about electron configurations, you were shown a little filling order diagram to help you remember the order in which things fill up. And you're always remembering that we're filling from the lowest energy level, the shell nearest the nucleus, the subshell nearest the nucleus, going outwards and therefore upwards in energy. Okay, so your filling order diagram, you might remember, looks like like this: 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, and 4f. So lowest energy level, higher energy levels. And we always fill from the lowest energy level working outwards. So 1s, 2s, 2p, 3s, 3p, 4s. Takes us to this point here. So therefore the next subshell that would fill is 3d. And then after that, it's 4p. Question B. What is meant by an orbital? Another definition, third one of the test paper. So quite a specific wording for your definition for this one. So you need to make sure you get the wording correct. All right, so we're looking for the region or area in an atom that can hold up to 2 electrons with opposite spins. You might remember we represent the opposite spins with the up and down arrows in your arrows and boxes diagram. So specific wording, you must mention the fact it's part of the atom. Okay, 2 electrons, opposite spins. State the total number of electrons in occupying the p orbitals in one chlorine atom. Now this question is very commonly misinterpreted. If you don't stop and read it properly, you might be fooled into thinking it's asking to write the number of electrons on a p orbital, which is 2. It's not asking you that. Look again at the question. It says state the total number of electrons occupying p orbitals, it's pluralized, in one chlorine atom. So all you have to do is try and think about and visualize the chlorine atom. So if we write out its electrical configuration, 1s2, 2s2, 2p6, 3s2, 3p5, 17 electrons in chlorine. And you can now see that we're looking for the total number of electrons on the p orbitals. Well, there's 2p and 3p. There are my p subshells and therefore my p orbitals. There's 6 electrons on the 2p. There's 5 on the 3p. 6 plus 5 makes 11. So there are 11 electrons in total on p orbitals in one chlorine atom. Part C. State the electrical configuration for a calcium 2+ ion. So watch out for these configurations. When they're asking you for an ion, it's very easy to miss it or do the wrong thing and put electrons on when you should have took them off, or vice versa. It's a 2+ ion. It means it's lost 2 electrons. To form a positively charged ion, it must have lost 2 electrons. So if we go for the calcium atom and then take the 2 electrons off, 1s2, excuse me, quick rub out, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 for a calcium atom. Its lost is 2 outermost electrons, the 2 from the highest energy, which are these 2. So those ones are the one that's lost. So there's your answer. The configuration for a calcium ion, 1s2, 2s2, 2p6, 3s2, 3p6, making it the same as the argon configuration. Remember, when electrons lose or gain when atoms lose or gain electrons, they're looking to form the same electron configuration as their nearest noble gas to make it stable. Question D. Complete the arrows in boxes diagram to show the arrangement of atoms of electrons in an atom of nitrogen. All right, nitrogen has got 7 electrons. Its configuration would be 1s2, 2s2, 2p3. So we're looking to put the arrows in the boxes correctly. Remember, we're always filling from the lowest energy level going upwards and outwards. So 1s is first, 1s2, 1 up, 1 down. Remember, the opposite spins represented by up and down arrows. You can have full-headed arrows if you want to. It makes no difference at this stage. 1s2, same for 2s2, 1 up, 1 down. Now the 2p3 is where you've got to be careful. Remember, when we have a subshell, when we have more than one orbital in the subshell, electrons fill 1 per orbital and then go back and refill them afterwards. All right, it's due to the repulsion. Remember, they're all negatively charged. So when the first electron goes in there, so the 2p1 electron, 2p2 will come along and will be repelled into the next orbital. So then 2p2, same thing for the 2p3, tries to go in there, gets repelled into the next orbital. So you must have one arrow in each box. Doesn't matter if they're all up or all down, as long as there's one in each box for your 2p3. And question E, to finish off this section before the multiple choice, it's asking you simply to state the number of electrons in these different parts of the atom. A 2p orbital, that bit is completely irrelevant. The fact that it's 2p doesn't make no difference because it's asking you for the electrons in an orbital, and we know an orbital can only hold 2 electrons. 3d subshell, 3-bit is irrelevant, doesn't matter which energy level it's on. A d subshell can hold up to 10 electrons.